Welcome to the Explainer. Today, we're going to crack open a topic that can seem a little complicated, mix and yield variances, and turn it into a simple detective story. We're going to find the hidden clues inside your efficiency numbers.
So here's how we're going to solve this efficiency mystery. We'll start with the puzzle itself, then find our two big clues, the mix variance and the yield variance. Then we'll see how they work in a real-world case, figure out what the evidence means, and wrap it up by testing our new detective skills.
All right, let's set the scene. Every manager gets these reports, right? But what does a single number, like an efficiency variance, really tell you? Well, usually it's not nearly enough to figure out what to do next. When you see a big top-level number like a direct materials quantity variance or a labor efficiency variance, you're really just seeing a symptom. It tells you that you were off plan. But a negative number just sits there on the page, kind of judging you. So what do you actually do with that? That's the problem we're going to solve today.
And that's the real question, isn't it? What specific decisions about your resources, your materials, your people led to that number? To get to the bottom of it, you've got to break the puzzle down into smaller pieces. And this is where our detective work really begins. So, our first clue is all about looking at the specific combination of inputs we used. The best way to think about it is like a recipe. The mix variance looks at the recipe you actually used versus the one you planned to use. The big idea here is that you can often swap things out. Maybe you use a senior developer instead of a junior one, or a higher grade material instead of a standard one. The mix variance is the tool that tells you the financial impact of making those specific swaps. So what this really boils down to is cost. The mix variance tells us if the recipe of inputs we used was more or less expensive than the recipe we budgeted for. It's purely about the cost of the combination, which sets up a really fascinating question. Is a more expensive recipe always a bad thing? Okay, let's not get scared by the formula. It's actually pretty simple. ATQ is just the actual total quantity of all the stuff you used. The interesting part is in the parentheses. Think of SMSP as your planned average cost per unit of your recipe, and AMSP is the average cost of the recipe you actually used. So the formula just figures out if your actual recipe was cheaper or pricier than you planned, and by how much. All right, let's move on to our second clue. This one looks past the cost of the recipe and focuses on the results. Now that we've isolated the cost of the mix, we need to ask, for all the ingredients we put in, how much did we actually get out? The yield variance is our ultimate productivity measure. It totally ignores the specific mix and asks a really basic question. To get our final product, were we wasteful or were we efficient? Did we use more total hours or materials than we should have? Or did we somehow manage to use less? And the formula shows this perfectly. We compare the standard total quantity, or STQ, that's the total amount of stuff we should have used, against the actual total quantity, or ATQ, which is what we did use. If we used less than the standard, we get a favorable variance. Simple as that. We were more productive. Okay, theory is great and all, but this is where the mystery really gets solved. Let's see how our two clues, mix and yield, help us crack a real-world case about a retail store's staffing. Here's our evidence. The store planned its staffing mix on the left, but what actually happened is on the right. Now notice the big changes. Manager hours went way up, from 100 to 120, but warehouse hours dropped like a rock, from 500 to 380. That is a huge shift toward more experienced and, more expensive labor. Let's see how it all played out. So first, we need our baseline. Based on their original plan, their standard recipe, the average cost for 1 hour of work was $12.75. This is the perfect world number they had on paper. But because they ended up leaning more on those higher-paid managers, the average cost of their actual mix of people jumped to over $13.25 an hour. The recipe definitely got more expensive. So you plug that into our first formula, and boom, a $755 unfavorable mix variance. This is our first clue. And looking at this by itself, it really seems like they made a mistake. The staffing choice cost them more than they planned. But here's the twist in the story. Look at the yield. The plan called for 1,600 total hours to get the month's work done. But this new team, they crushed it in only 1,500 hours. They were 100 hours more productive than anyone expected. And that gave them a massive favorable yield variance of $1,275. So wait a minute. We've got one clue pointing to a costly decision and another one pointing to amazing productivity. So what's the real story when we put them together? This is the moment where the data tells us what really happened. Check this out. When we put our two clues together, the whole picture just snaps into focus. That $755 unfavorable mix variance is completely wiped out by the huge $1,275 favorable yield variance. The bottom line? A total efficiency variance of $520, favorable. The big picture was a success, and now we know exactly why. And this right here is the powerful insight this gives us. That decision to use a more expensive labor mix wasn't a mistake at all. It was a brilliant trade-off. The extra cost of using more managers was an investment that paid off big time in superior productivity, leading to an overall win for the store. Okay, that was a lot to uncover, so let's do a really quick check to make sure the main idea here is crystal clear. All right, take a look at the question. When you add the mix variance and the yield variance together, what single high-level variance do you get? And the answer is C, labor efficiency variance. If you got that, you've absolutely nailed it. They are the two parts of the story that together explain the whole thing. Excellent. And this leaves us with one last really powerful thought. You know, our retail store might have just stumbled into this great result, but what if it was intentional? As a manager, when would you deliberately choose a more expensive mix of people or materials, creating an unfavorable mix variance because you're betting on a huge payoff in productivity? Now that you know how to crack the code, you can use these tools not just to analyze the past, but to strategically engineer a more successful future.